So in the previous video, I explained the difference between capacitor and inductor in general, in everything, in the relation, the symbol, and so on, current voltage relation, and so on. So this part is just a repeat for what I have mentioned before. So as a capacitor, as you see, is a passive element that store energy in terms of electric field, and you see it is just two parallel plates like this. Sometimes it is separated by the electric material with certain permittivity. You call it permittivity epsilon. And the inductor is a passive element that store energy in terms of magnetic field, and usually it is a coil like this. You see, it is a coil. And it has some. You can calculate the inductance using the number of turns, and the material inside. We call it here permeability, mu, and the length of the coil, and so on. Okay. So here, for example, this is a relationship here for calculating the capacitance. So the capacitance is C is Q divided by V, or the charge divided by the voltage, or you can call it here epsilon. If you have two parallel plates, it is epsilon times A, which is the area of the plate, divided by the distance, which means that if you want to increase the capacitance, you have to increase the area, and you have to decrease the distance. So if you increase this this A is the area, and decrease the distance, you can increase the capacitance. Also, you can increase the capacitance by increasing this epsilon of the material. For the inductor, this L here, the inductance equal N square, which is the number of turns, and mu is the permeability of the material inside the coil, and A is the cross-section area here. And this slide is just as a relationship between current and voltage in both inductor and capacitor. As I said before, the capacitor acts as an open circuit in case of DC because it's just parallel plates, and inductor acts as a short circuit in case of DC because it is wire but you wrap it. So this is how we look. How is it? You can, when you solve a problem using it that has only DC. If you have only DC, it's very easy. Replace the capacitor by open circuit and replace the inductor by short circuit. Also here, this shows the energy stored in the capacitor and the energy stored in the inductor. Then the series and parallel relations in the inductor is very similar to resistor. So as you see here, if you have some resistors, inductors in series, you just add them, exactly like resistor. But if you have them in parallel, you add the reciprocal. So you apply also the same relation. If you have two inductors in parallel, then you multiply over the summation. And if you have multiple inductors that have equal number or equal inductance, all of them parallel, then in this case you just divide the inductance by number of inductors. The capacitor is completely opposite. So if you have capacitors in series, you add the reciprocal and you apply the parallel rules. So if you have the capacitors in series, you apply the parallel rules. But if you have capacitors in parallel, you apply the series rule, which means that you add. This means that if you have capacitors and you want to increase the capacitance, you want to connect them so that you can increase the capacitance, you have to connect them in parallel. You connect them in parallel, not in series. Next part here is this slide has some questions. We will solve them in the next